Hi there, I'm Kyle Hunder. I'm a solutions architect on the professional services team here at Imply. In this video, we'll talk about the components that make up an Imply Druid architecture, the function of each of them, and how the cluster operates at a high level. We'll start with the basics. What is Druid? Well, Apache Druid is a real-time analytics database designed for fast slice and dice analytics or OLAP-style queries on large datasets. Druid's distributed architecture allows for horizontal and vertical scalability of event-oriented data and allows immediate querying of streamed, real-time, or batch-ingested data. In order to understand how this all works, let's take a look at the components of an Imply Druid architecture and each of the processes in these server instances. Starting with the data server is responsible for the ingestion of data, either batch or streaming, and the bulk of query processing. The data server runs three process types: the historical, the middle manager, and the peons. The data server also communicates with deep storage, sending and receiving data from this shared storage pool. We'll talk a bit more about each of these processes after we cover the other server types. Next up is the query server. The query server is responsible for accepting and executing our queries, and for our graphical user interfaces. The query server also runs three process types: the pivot user interface, the router, and the broker. Then there's the master server. The master server is responsible for the control and coordination of the cluster. The master server runs the coordinator, overlord, and zookeeper processes. Druid uses the zookeeper to facilitate inter-service communications in a decoupled fashion. Last, we have some external dependencies: the metadata database and the deep storage. When using the Imply Cloud, the metadata DB is an AWS RDS MySQL instance. If we want to understand how these processes are utilized in our operations, let's go through some examples, starting with ingestion. The ingestion process begins with a specification called an ingestion spec. In this JSON file, we tell Druid things like if we're ingesting from a Kafka or Kinesis batch stream, or batch processing from an S3 bucket or HDFS file system. We send this ingestion spec to the overlord using an API call, or using the router UI to guide us through the process. The overlord then finds a middle manager with available processing slots, or peons, and allocates the task. As the data is ingested, we tell the broker about it, so it can be queried. Once a chunk of data has been ingested, we form a segment and transfer it to deep storage and update the metadata database. When we're ingesting streaming data, we use a supervisor to do this on a regular schedule. Now, having our segments on deep storage is good for resiliency and distribution, but not the best for speed. And this is where the coordinator and historical processes come in. The coordinator retrieves a list of in-use segments and instructs the historical nodes to load the active segments locally. Keeping all active segments locally on the data server enables us to use various caching mechanisms, such as the Linux file system cache, to keep as much of our data in memory as possible. If appropriately sized, Druid can keep all our data in memory and keep our queries super fast. So for our next example, we'll have a look at the query flow and the processes involved. In the example of executing a query on the Imply Pivot UI, Pivot sends a query to the router, which passes the query to a broker. The broker has an understanding of where the data lives and executes subqueries to gather all relevant information. If this data is real-time, as in it is still being ingested, the broker will query the peon processes. If this data has already been persisted, it will query the historical processes. The data is then assembled in the broker and returned to Pivot. Thank you.